Okay.
Happy Monday, everybody. So
Happy
we are
Monday.
live. I mistakenly put down the wrong time zone for the meeting, so hopefully this works. For people on LinkedIn, I guess you'll just get a pop-up that I'm on another link here, which I'll post in the original chat here. But anyway, time zones. We were chatting about it, but it's not as not as fun as your story there, Amit. So
Yeah, that was a good one. How many time zones have you been in the last month, Joe?
Sorry. Cool. So anyway, sorry, I'm trying to figure out this thing here.
Oh, okay.
Awesome. Sorry. Cool. Getting started here. Sorry for the technical difficulties. Yeah, I think we're live now. Yeah, apologies to the audience. Apologies to Amit and everybody. Cool. So for people who don't know who you are, do you want to give a quick intro?
Sure. So my name is Amit Prakash, and I am co-founder and CTO of a company called Thoughtspot, where we basically, our job is to make consumption of data insight and generation of data insight as intuitive and as easy as possible for anybody who needs insight from data.
Awesome.
And yeah, we've been around for the last 11 years, and the most common thing that people know us for is this Google-like search bar experience to be able to ask questions and get answers.
Mm-hmm. Yep. Yeah, you've been at the foray for, I would say, like kind of semantic search. Is that what you call it, or how would you describe what Thoughtspot does?
So we call ourselves the experience layer of analytics, and the idea is to build enough intelligence in the platform so that users can ask their data questions the way it makes sense to them, as opposed to learning some sort of technical language or some drag and drop UI to be able to figure out how to ask data questions. This applies to sort of asking questions straight up in natural language, having a conversational interface to be able to build up the question, or like take an existing visualization or a question and modify it to get to your answer, all those things.
And where did you get the inspiration from this? Because it would say at the time you guys started, BI was very much, it was all about dashboards, drag and drop, maybe enter some SQL or something like that. But you guys took a completely different approach, I would say, than a lot of other companies.
Yeah, so we were getting started in 2012, and we looked at this analytics space, and it clearly seemed like all the signals were there that data is very important to the industry, and every CIO in the world was looking at how do I give better access to data to my counterparts and customers. And the two tools that were doing really well in those days were Tableau and Click. And a lot of what in those days, if you look at the marketing of Tableau and Click, what they were talking about was that you can essentially get a small extract of your data, and we'll put that in the memory of your desktop, and that allows easy access to insights from that data. And the interface was significantly better than what the previous state of the art was. But when we started talking to customers and started looking at the details, we realized kind of two problems. One, that this thing wasn't scaling to the need that the enterprise had. So like, even if you moved from desktop to server, you were limited by maybe 100 million rows or something like that. And the second thing was that despite the claim of being intuitive, and it was definitely intuitive more than the previous generation, it was still not accessible to most business users. And I think a point of epiphany was that we went to one of their user conferences, and they had a reference customer who came on the stage and said, like, now our analytics is so amazing that every time you need a new report, all you need to do is go fill out the 6-page HTML form, and within a week, we'll have a report ready for you.
Wow, that's amazing. How do I sign up? I got to fill out a 10-page form for that. So
I mean, I feel like that's still the state of the art at a lot of companies. It might be like 6 months.
That's crazy. That actually happened.
Yeah. This was like proper user conference, reference customer on the stage talking about this thing. And so we kind of looked at it and chuckled to ourselves and said, like, we could certainly do something better than that. And it was several months of iteration and searching for the right solution. I had my background in search. So I'd worked on very, very early stages of the search engine that became Bing. And then I was doing machine learning at Google. And so we looked at it and we said, the ideal thing would be that we could use an interface almost as universal as Google for people to be able to just ask questions and get answers. Now, on the flip side, we realized that we're not talking about an internet search engine where you find 10 blue links and give it to the user, and the user is responsible for figuring out what it is that they're looking for and which one is relevant, which one is not. In business, if somebody asks, like, how much revenue did I have from Southeast Asia in last 6 months, that number needs to be precise. Number needs to be something that people who are responsible for data can govern, and the business user can trust. And like, two people asking the same question shouldn't get two different answers. And there can be almost no ambiguity left in there. And so we realized that it wasn't quite as simple and easy as building another search engine. There has to be a strong UX component, there has to be deterministic translation, and there has to be a lot of input from people who really understand data. So that was kind of the beginning of our journey initially, because the NLP space was not as mature. We took a very different approach, and we said that our job is to keep the system deterministic, but bring it as close to Google-like experience as possible without giving up the determinism. So the initial approach was actually to look at all the business entities that a particular company or a particular group of users care about and build a language around those entities automatically, and then give them an experience which feels like search, but they're actually using that language that's very familiar to them and asking the question. And over time, obviously, we have evolved.
Well, and I want to ask you a question about that evolution. You worked on Bing. Bing, obviously, in the last year, went through some pretty big changes. And I think those changes are relevant to you as well. What do you want to talk about that a bit?
So when we were getting started, I just come out of my PhD. And
what was your PhD in, by the way?
Oh, my PhD was mostly around algorithms. So the title was Algorithms and Architectures for High-Speed Routers. And so, unrelated to what we're talking about, but it was a fun exercise in math and algorithms.
Cool.
So I was getting out, and the people at Microsoft made me a very compelling offer, which was to basically be at the ground zero of building sort of the next competition to Google. And what we ended up building in those days was a lot of distributed systems infrastructure to be able to handle large-scale web and sort of implementing variations of well-known algorithms to kind of keep improving search. So by the time I got out, which was 2007, so 2003 or 2007, we ended up building a lot of distributed systems and a lot of sort of search ranking algorithms and iterating on like neural nets early on, and like PageRank style graph algorithms and things like that. Obviously, Microsoft has been on fire because of their partnership with OpenAI and having early access to GPT. They've been doing a lot in that space, and so have we. And it's what people don't get about generative AI usually is that it's not so much about the chat-like experience and human-like language generation. It's really a reasoning engine, and a reasoning engine of the kind that we haven't had before. And that allows basically to fundamentally build new kinds of products. And that's what we've been doing here at Hotspot, where the vision was already there. A lot of infrastructure to enable it was already there, but just adding a little bit of real world common sense reasoning capability into the system makes it dramatically better.
So you used the word deterministic a few minutes ago to describe
Yeah.
sort of your goal.
Yeah.
With Thoughtspot, I would call it maybe Thoughtspot 1.0, but now you've with the generative AI component that's inherently stochastic, I suppose, and not deterministic. How do you make that switch?
So we've always had this hypothesis that what experience we're building, user experience design is going to be a critical element of it. And both in terms of allowing the users to be able to ask meaningful questions, to become data literate, as well as providing trust to them that whatever they're looking at, they can trust. And like in general, when people talk about LLMs and GPT, they're often talking about like hallucinations and like it's good and all, but like you can't really trust the result. The way we've been able to do this is we take users' question and then we translate that into the language that I was just talking about, the dynamic language that we create for their content, for their business entities. And so we take your question, we turn that into that language, and from that language we go to SQL. And the advantage of doing it that way is that going from natural language to this intermediate language, all the ambiguities are resolved. So you can read that question and you'll know exactly how your question has been interpreted. But yet it's not like a programming language or SQL where you need technical expertise to parse that and understand what's going on. So that allows users to ask a question, look at the interpretation, and see if this is what they meant, which 90% of the time it would be, but 10% of the time, if it's not, they have the ability to go and modify that language and then get the right result. And our system learns from that. So now, not only have you gotten high quality result that you can trust, you've also taught the system what is the right way to interpret a given class of questions. And that's how we are able to keep sort of both the stochastic nature of LLMs, but still give a deterministic experience. So to give you a concrete example, let's say if I go in and ask a question like, what are my best performing products in last 6 months in California, right? So there's a lot of ambiguity in that question. What do you mean by best performing? Is it ranked by revenue? Is it ranked by profit? Is it ranked by profit margin? And then there's a lot of ambiguity about what do you mean by last 6 months, because it could be the date on which the products were shipped. It could be the date on which customer ordered, or it could be the date on which you actually recognize that revenue, if that's different, right? And then the third piece of ambiguity is what do you mean by California? Is it the state where the customer lives, or is it the state where the store is, or the warehouse where you ship from? And different companies will have different variations of this thing, right? So what we will try to do is take that question and turn that into this language that will say top 10 products ranked by profit, where ship date was in last 6 months and user state is California, right? And so as a user, you can look at this and say, wow, this is exactly what I meant. Or you say, no, this is not what I meant. I need the store state to be California. And you can make that change, and that eventually gets turned into SQL, and then you get the data visualization.
Is there a situation where the interface actually asks those questions that you asked in your scenario, like when you say California, what do you mean by California, and that sort of thing?
Yeah. So we have heavily relied on this language and all the interface we've built around this language to resolve these kinds of ambiguities. But at the same time, we are also working on a conversational interface, which is more like a regular chatbot kind of thing, where you ask a question and you get a response, which could be a data visualization chart, or could be a table or a number, or it could be a disambiguating question or anything else as appropriate. So that thing is in the works. It's probably coming out in a couple of months.
Cool.
And that allows you to ask much richer questions as well. So, I mean, this kind of ambiguity is easily taken care of by a current interface. But what if you wanted to ask questions like, what were my top 10 customers last year? And of those customers, how many are still spending more than $1 million this year?
Yep.
And that sort of stuff is a lot easier to do when you have a multi-turn conversational interface. And that's why we're working on that stuff.
That's super cool. Because I mean, as somebody who's worked as an analyst before, and I'm usually an annoying person that's asked like, so what do you mean by this, this, and everyone's just like, can you just go away? So
well, except when they get inconsistent answers, then they always get upset, right? It's like,
to
ask so many questions.
Yeah. Speaking of questions here, we do have some questions in the audience. Good questions here. I'll start off with Mark since he asked first here. He says, prompt engineering seems difficult to me. How can we create training for future analytics use cases to increase quality of answers from generative AI? Any thoughts?
So I think prompt engineering may seem difficult, but actually it's a very powerful tool. And anybody who's trying anything with LLMs, I would say always first shoot for high quality prompt engineering and see how far you can take it before actually getting into fine tuning or training. I think it's a broad advice, may not apply in all cases, but majority of the cases, it turns out to be good advice. The other thing is that in general, my 20 years of building machine learning systems experience says that you never shoot for the ultimate system that you're trying to build on day zero, right? What you do is you build a system very quickly so that it delivers some value to your end users. And then the end users start using it, and that gives you the license to learn from how the users are using it. And also with end users' permission, you can generate some training data and use that to improve the system. And then the system is more usable, more users come and use it, and then you have more training data and you get into this virtuous cycle. So that's another reason to start with prompt engineering and then have enough data, because even though you can get pretty good results with maybe 10,000 training samples in fine tuning, I think it's much better to have high quality and substantial amounts of training data before you foray into any kind of fine tuning or training from scratch.
What are you finding out in the wild with these generative AI models? Because it seems like corporate data sets in particular, some of them are big, some are small. Like what is there a sweet spot in terms of the amount of data that you want these models to be trained on and fine-tuned on?
So I interpreted that question slightly differently. So let me answer both versions of the question. So the first one is like, if you are in a corporate setting, your data sets may be large. They may be not just large in number of rows, but in complexity, right? Like there may be 20 tables involved, and there may be like thousands of columns involved in those use cases. And does generative AI work in that case or not? That was not the question you were asking, right?
No. The question was really, in terms of data sizes, especially when we're dealing with, say, data warehouses or corporate data systems, right? It's like, it doesn't seem like a lot of companies, when we're talking about SMBs or kind of maybe even large companies, and we're not talking Fortune 2000s or whatever, but the data sets aren't huge. They're not Google or Amazon scale.
So in general, there's a range of numbers that you hear from people who are training these models, and depending on the use case, you could get decent results from fine tuning even with like 1,000 training examples. I've seen even people claim getting decent results with like 100 training examples. what we are seeing for SQL use cases is that, like, I think maybe 10,000 is the minimum bar before you start seeing reasonable improvements over the foundation model that you're training on.
Interesting. Got a question from Sarab here. What kind of effect will LLMs and prompt engineering have on data analytics and product management?
So, like I said, I think the most interesting aspect of LLMs is that they are little reasoning engines. And like, for example, you can say that when somebody is asking a question about opportunity creation in a Salesforce dataset, their date filter should apply to creation date. But when they're talking about winning business, their date filter should apply to close date. And you can give that instruction, and then you can ask questions, and it'll disambiguate based on that. And that takes like human-like reasoning. And I think that's the most powerful aspect of LLMs. And granted, today, LLMs are not very good at it. Like, they can do maybe one or two steps of reasoning somewhat reliably. But if you have to do 5 hops of reasoning, there's maybe 10% chance that it will get it right. So talking about what's happening today, I think basically if you can take care of everything else, but you still have like 1 or 2 things to reason out based on the context, you can apply LLMs in those contexts, whether you're solving an analytics problem or whether you're solving some sort of a product question. So, and this applies to all aspects of data analytics, right? Like whether you're preparing data, whether you're cleaning data, whether you're trying to guess different synonyms for columns, when, like, what language would somebody else use to ask this question? So your column may be called like RX355 or some cryptic thing because it came out of SAP or ServiceNow. But these LLMs actually have enough knowledge that you say, like, this came out of this app. What should be a common business name? Chances are, more often than not, they'll give you a right name. So that's just an aside. But like, I think in general, a lot of things that used to require somebody to be embedded in that context and know that context, that knowledge is now there in LLMs, and you can try and automate some of this stuff as long as the length of reasoning chain is not too long. And as time progresses, that length and like more improvements happen in LLMs, those things will get longer and longer. Like, longer reasoning chains will become more reliable. So I think at some level it's just like another tool in the toolbox for building products or doing data analytics. At another level, it's like one of the most interesting tools that we've had in a while.
How do you deal with the hallucination problem? I mean, do you see this coming up? Do you see LLMs returning just like wild, completely off the rails answers in some cases?
Yeah, so I think if you can take a few steps back and look at what people are using LLMs for, they provide 2 things. One, it's knowledge base, right? So you rely on LLMs to give you facts around the world. Like, in my case, let's say if somebody asks a question, what's the longest movie ever on an IMDb database? You need to know that longest in the context of movie means the duration column. Whereas if somebody says, what's the longest bridge ever, in that case, you're talking about the length of the bridge. And if somebody says, what's the longest name of the customer, you're talking about string length of the name, right? So this is where you're relying on LM to know facts about the world. And then the second part is reasoning, which is the example I gave earlier. So I think the more you rely on LLMs for reasoning and less on facts, the less the chances of hallucination. Because what it tends to do is, if it doesn't know a fact, it just makes up one. And this is why prompt engineering is interesting, because what you can do is you can fetch all the facts about what you're asking the LLM to do and put that in the prompt. And that dramatically reduces the chances of hallucination. So that's one thing. The other thing is, if you straight up ask LLM to answer the question versus if you ask LLM to generate the code to produce the answer, again, the chances of hallucination goes down dramatically, because then that piece of code can actually access the facts in your database or wherever it lives, and based on that, answer the question. So basically, these are the two things that we have heavily relied on to build a product. And of course, the third thing is, if you have human in the loop, how can you build the right user experience so that they're not fooled by an LLM mistake and they catch it and say,
Interesting. See, Jason Taylor, aka LinkedIn user, he has a question here. We've been hearing a lot about the combined powers of large language models and knowledge graphs. Curious about your thoughts and whether this could go well or not. So knowledge graphs. And, yep.
Yes. So this definitely matches up well with what I was just saying, is that if you know certain facts that will be helpful in deducing the answer that you're expecting the LLM to give, put that fact in the prompt. And then the task of reasoning is easier for LLM, and it doesn't have to rely on its own fact base, and hallucinations go down dramatically. The thing about knowledge graphs is that people were trying to build knowledge graphs for a while, and they had somewhat rigid structures. And they, like, if you have sort of a regular structure in your information, then knowledge graphs are great. But if the knowledge is somewhat amorphous, you can't really represent it in knowledge graph, right? Like a simple example would be like, you could build a knowledge graph about sort of X belongs to Y kind of thing. And so you can say, like Amit belongs to the Thoughtspot organization. Yeah. And that would be a good representation. But then there's no way of representing in that knowledge graph that Amit was at Hotspot from 2012 till now or something like that.
Right.
Because now you're adding a whole new dimension, and you may have thought about it and encoded in your knowledge graph, and you may not have. There may be another aspect of that relationship that you didn't design for in your knowledge graph, and in certain contexts that's relevant. And this is where LLMs are really good, that like they don't need a predefined data structure to represent knowledge. So knowledge graphs are great, but they can't capture everything.
Right. See, Nilesh has a question here. Yes, what is lacking in the current data observability or quality tooling, especially with regards to helping generative AI? Any thoughts on that?
I'll have to think about that one.
Yeah.
I think like data observability and quality tooling is, a lot of it is about human intuition, right? You can look at numbers, like you usually get 1 million records a day in your database from your transaction systems. Today, there are only 500,000. It could be because something bad has happened in your data pipeline, or it could be because there's an event going on that's causing people to focus somewhere else. And that sort of stuff ends up being really hard to just program in the system. And That's where AI is super helpful. Now, people have been trying to do this with like time series forecasting algorithms for a while, but this is where I think generative AI could be super useful in like your traffic is down because everybody's watching a football game kind of thing is hard to do with sort of hard-coded algorithms. So that's one example that comes to my mind. The quality again, I mean, like sometimes there are a lot of nulls in the data, and that means the data's problems sometimes is just expected. And how do you weave all the business context in reasoning about that? That whether what you're seeing is a quality bug or is to be expected given the business context. I think the more so what happens is that people have been trying to do all this using classical ML techniques, right? Like anomaly detection, time series forecasting. And when you do that absent business context, then you end up producing a lot of noise along with signal, and people get tired of that noise. So if you can weed out that noise by having more intelligence and knowledge of your business context, you can build better tools. That's what I can come off the top of my head, not having thought about it at all.
That's really interesting. I do have a question about now that we're unleashing generative AI onto corporate data sets, how important is the underlying data model that you're encountering? Does it matter at all? Can the data be just in any shape or form, or is a better data model, does that produce maybe better results and context?
Yeah, absolutely. I think data modeling will continue to be the foundation of these experiences. I mean, like most people that I talk to say, like, if in a couple of years AGI is here, then we don't know how to talk about it and what will be true,
Right.
what will not be true. All the assumptions go out of the door.
It's
But
all out the window.
until such a time that like we have these powerful AI tools, but they are not like human level intelligence, I think the more context we can provide through data modeling, the easier it gets for them to serve us well. So in case of Thoughtspot, like Worksheet is our data modeling layer, and that plays a huge role in providing high quality answers to end users. And that's also our governance layer, right? So it's not just that you don't want to like, it's not just like, oh, you have to do data modeling to be able to get answer. Like
Right.
you want to do it so that you can control the behavior that AI is showing. Like you don't want it to come up with its own interpretation of what your profit margin should be, how your profit margin should be calculated.
Maybe it has a better idea. I don't know.
Maybe.
So you've been doing it wrong the whole time. These other companies, they've been doing it this way.
It turns into like this crazy radical venture capitalist that comes out with outrageous valuations for your company.
Yeah, I mean that would be interesting though. I mean, I see this as being some sort of a product of some sort of is a sort of this I don't know if it'd be anonymous, but benchmarking other once you get enough data, this large language model could say, oh, well, other companies in your vertical are doing. It's no different than how companies have been benchmarking for decades anyway. But I think it would be interesting to get a very prescriptive, I would say jokingly bullying kind of a AI that's just like, you guys want to make money or not? Like these other companies are killing you. So it's should
No,
be
so I think that's one of the interesting things about generative AI, that it can be a good sort of intellectual sparring partner, a very dumb one, but nevertheless like better than rubber ducking, right? So a lot of times for hard problems, like rubber ducking helps a lot, where like you just put a rubber duck on your desk and you try to explain it to that rubber duck, and it doesn't give you anything back, but just the act of trying to explain it makes your job easier. Similarly, like if you're trying to brainstorm something, I often sit in front of these LLMs and say, like, I'm thinking about X, Y, and Z. These are my thoughts. what do you think? And it almost never gives back anything of value that I could just straight away lift up. But having that back and forth helps me think better and come up with better ideas.
It's like the classic Turing test, right? It
Yeah.
sort of convinces you that it's human and thereby enhances your own thinking just through the
Yeah.
interaction, like the idea that there's someone on the other side listening to you.
Yeah.
It's interesting. I actually got a couple questions here from Mark Keeling. Does generative AI need metadata to be provided, or can it get the context it needs from the data itself?
I mean, it can, but it's not very good. So I think there's this idea that like every industry that relied on somebody producing a draft and then somebody else reviewing it, I think the job of somebody producing the draft can be kind of automated, right? So you can ask Gen AI to produce the metadata, and it'll be a draft version, and maybe you can spend 20-30% of the time you would have spent building that metadata, but you still have to do it, otherwise it's not anywhere close to the reliability that, like, if you asked an intern to do it.
That's interesting. I guess back to the data modeling question here. Jason asks, how is data modeling changing? Have you seen any companies change the way they've been doing data modeling in light of large language models?
So I think that's a very interesting question, and this is something we've been pondering for a long time. So
Interesting.
our metadata layer encapsulates a lot of things that usually you won't find in metadata model of other tools, because we've always been focused on how to allow people to be able to ask questions and give answers. So for example, like the simplest example could be, do you know if this column represents a person or a place or money or an organization? If you know that, answering the question like, who's responsible for this account becomes a lot easier, because who implicitly implies either a person or an organization, right? Like you can figure it out even otherwise, but knowing that helps. Similarly, it's hard to find out when a data is pre-aggregated or not. And depending on that, the way you write SQL can change. So for example, if I say, how many iPhones did I sell in last 3 years? If my data represents one row per transaction, I can just do a count query. But if my data represents hourly sales per store, then I have to sum up that column. And knowing that is useful if you're trying to generate natural language to SQL queries. And so those are the kinds of things that we've been baking into our metadata modeling layer for a while, so that it becomes easier to answer questions like that. And like I just give you sort of two sample from this a lot of vast ocean of knowledge, and not all of this needs to be explicitly specified by a human. A lot of this can be inferred, and then there can be a feedback loop that can be used to correct these things. But definitely it makes sense to have more semantic metadata around your data to use these models more effectively.
That's really interesting. Just to wrap as a related question here, I guess this may be the inverse, is how reliable is generative AI for data modeling?
Like I said, it's a good first draft.
Yeah.
It's not something that you want to rely on. It might save you maybe a bunch of effort. So like, I'm throwing out a random number, but like if you're going to spend 100 minutes on data modeling, maybe with Gen AI, you can get it done in 20-30 minutes.
It's pretty significant though.
Yeah.
Yeah. The problems I've seen is it still need to give it the context and the domain expertise of your business. It can only read what it can read, and it's like, I don't know. So yeah, that's interesting. I guess, before we started, we're kind of we're talking about your Thoughtspot's journey into generative AI, and what was it like scaling up a team, right? Because I mean, you guys have been in sort of tangentially related with the semantic search for a long time. What was it like upskilling with generative AI?
It was a very interesting process, and the one that we enjoyed a lot. So a little bit of history. So like I said, initially Thoughtspot's approach was to look at the data model, look at the metadata, and generate deterministic language for every use case that people can use to ask the questions. And this worked well for us, but it always sort of surprised some people in terms of, like, they looked at a search bar that looked like Google and they wanted to ask, like, what was my revenue last year, or what are my best performing products, as opposed to saying top 10 products ranked by revenue, kind of thing. And so we started in 2017 trying to build a natural language interface that is layered on top of this DSL. And this is like before anybody was talking about DSL, talking about generative AI or anything like that. This was even before the Bird paper or the original Transformer paper came out, right? So the best technique that we could use in that era was similar to how speech recognition works, or used to work, which is that when you're trying to get a sound bite turned into words, you break it into phonemes, like sound of k, h, d, kind of thing. And then for each segment, you have a bunch of guesses that with 90% probability this sound k, but there's 20% probability this g, and so on and so forth. And then you try to string together your hypotheses with the highest probability sequence given the language that you're trying to generate. So so some sequence of sounds, even though individually they are the highest probability, won't turn into a word, but some other sequence of sounds, also relatively high priority but lower than the other one, but like it actually turns into words, so you emit that. So similarly, we would look at different segments of the language and say, oh, this could mean this particular value in this column, and this could mean this particular keyword, and this could mean this particular column, and you string together, that forms something that can be turned into query. We'll go after that. And we were able to get about 80% accuracy on very simple data sets with like 10 column or so. But as it went to more complex things with like hundreds of columns, the accuracy was never better than 50%. And so it never came out of beta. But as a result, we were constantly looking at this literature. We were building infrastructure that's necessary to be able to pull all the relevant knowledge for a given question, whether it's like the kind of metadata, whether it's like interpreting a fragment of text as a particular value in a particular column. And so we had built all this infrastructure, and we were also looking at, so when Bird paper came out, we were trying to understand it and see what's so special about the transformer architecture. We tried to use it. It didn't help us much back then. When people were talking about GPT-2, we went and evaluated it. And at the time, it seemed pretty primitive and it wasn't helping in our cause. But as a result, we were very familiar with this space, and we were watching it. And so in October of last year, we started looking at GPT 3.5, and we were really pleasantly surprised by how good it was as common sense reasoning. And so that's when we started working on this thing super hard. And we immediately pulled a lot of our best engineers, people who had some ML context, into a team that started working on eventually what became Thoughtspot Sage. So that familiarity helped, but at the same time, there's so much happening in the space. It was like drinking from fire hose. So all of us had to really stay like an hour extra or two extra every night reading the latest papers. We had like an internal Slack group called AI Learning, where
Wow.
anytime somebody would learn something interesting, they will post it there, and then everybody else will read those papers and talk about it. So we did in the last 3-4 months, we did hire at least a couple of people who came out of sort of traditional hardcore ML engineering or ML research teams. But until then, we had basically a lot of engineers who had some ML background and some bent of mind around ML. And we all learned together by either reading papers, watching lectures, videos, or just doing things. So I think a lot of it is just about just getting in there and doing small experiments, lots and lots of small experiments that you're willing to let go. That's been the key to bringing ourselves up to speed and getting to a good place.
Do you think this is going to be table stakes pretty soon? It seems like I see a lot of BI vendors starting to talk about how they're generative AI first. Do you think this is going to be a just sort of a prerequisite for a BI tool?
So I think everybody's product is going to improve because of generative AI.
Yeah.
But I think, fortunately or unfortunately, I guess fortunately for us, generative AI is not sort of the end product. It's not even close to the end product. You need a lot of other pieces to be in place to be able to build an intuitive experience for people to be able to get answers to their questions. So a lot of times what people are doing is just doing a quick project so that they can claim that generative AI is part of their product suite. So the easiest thing in the world is to feed some sort of an answer into generative AI and have it generate some natural language around it. And so people will talk about like dashboard summaries or like natural language generated insights, and it will be like you're looking at a graph there and it says like your customer base peaked in April, and since then there's been a 5% decline. It's not the most interesting use case of generative AI, but it's a use case, and a lot of people are doing that.
It sort of reminds me of back in, I would say, several years ago during the other ML hype cycle. Companies were coming up and saying, "Oh yeah, we have AI in our visualizations," but it ends up being like linear regression, like literally like a trend line. Like that's cute. So I think there's, but at the same time, I expect there's probably a lot of pressure on companies from their boards or their executives saying, "Yeah, we have to be an AI company now," and so whatever it takes to make that happen. So
I think you can take complex workflows and turn them into a chatbot-like experience. Right. So co-pilots abound. Like a lot of companies will come out with sort of generic co-pilot technology that you can embed in your product so that people can reduce the time it takes to do complex workflows and things like that. So those will be there in the products. I see some attempts of taking sort of contained report and then allowing natural language question answering on top of it. And that turns out to be an order of magnitude easier problem, because now you're in this very contained domain with just very few business entities and very small amount of data and limited number of questions that can be asked from that. So that you will see a lot of products doing. What we've been attempting to do for like last 11 years is like bring in your most granular, most detailed data models so that any question could be asked from that. And that has been a super hard problem. Like even all the investments that we made in last 10, 11 years, and even all the hard work that we've done over the last like year or so, despite that, it continues to be a super hard problem. So I think I can see kind of high 80s, low 90s kind of accuracy right now, but we'll continue to push hard on making it get as close to 100 as we can. I haven't seen anyone else kind of even attempt that in earnest, so I don't know where that what happens in broader industry. Obviously, everybody's working hard and trying to innovate, so there will be some interesting results, but that's where I see sort of the frontier.
I guess the title of the talk is the future of generative AI. I guess, in the last few minutes we have, what is the future? If you zoom out, like, let's say 5 years from now, like what does that look like to you?
So I think predictions are super hard in this space, even like a year or 2 year out.
You're not being held to anything, by the way. So just, don't worry about it.
Come back in 2 years. We'll have you back.
Yeah,
on.
man.
Like, why were you completely wrong?
You also plead the fifth on this one if you want.
Yeah.
No. I'll tell you what I am thinking, and it's not a prediction by any means. I think what needs to happen in this domain is that the ability to reason with longer and longer reasoning chains with higher reliability will just happen incrementally with more techniques. So if you remember, we had speech recognition even in late 80s or early 80s, but it will get every second or third word wrong. And as a result, it looked like an interesting demo, but you could never use it in real life. And somewhere in sort of mid 2000s, the reliability became so much better that it started showing up in products. And then in late 2010s, it just became something that you just relied on if you needed to. So I think there's a similar journey. And I think the ability to compress a lot of knowledge into a small set of just few billion parameters is very interesting. But the ability to take some facts and reason and produce new facts, whether it's mathematical theorems or like scientific discovery, or being able to execute a workflow where you say, like, in order to get here, I need to do this first and take the result, and then do that and take the result and do that. That thing, I feel like we are where speech recognition was in like late 80s. And as new advancement happens, whether in form of algorithms or scale or compute, I think that's where we are headed. And I don't know how far we'll get in 5 years, but substantially better than where we are right now.
Yeah, that'd be super cool to see. Yeah, it's anyone's guess. I mean, I think if you were to go back 2 years ago, this wouldn't have been on most people's radars. If you're paying attention to it, I think some people were actively working on it. But as you point out, even like GPT-2, that was 2019 or something. That was like pretty crude.
Yeah.
So I think during COVID, like, we were all dorking around the GPT-3 for a few weeks because we had nothing else to do except get on Zoom and nerd out on that. So, but then it kind of went silent for a bit, right? And all of a sudden, it's just it's funny. I was joking with Matt. You put a form in front of it's an HTML form from GPT-3, and it's just like, wow, it works. So it's like, how long have forms been around? Like, it's a long time. So yeah. So who knows what happens next, right? It just took a simple user interface to blow the doors wide open on this stuff, and everyone's attention changed. No pun intended.
But I think we're waiting to see what the real killer app turns out to be, right? We're right in the hype cycle, and it might be data. That might be the thing where these like really blow up first as a practical application, kind of like you were.
Well, because the stats on ChatGPT though, they've been going down all summer, which leads me to think that it's a lot of school use cases, right? So it's like I expect hand calculator sales probably went down in the summer too. Then all of a sudden it goes back up. So my kids are using it all the time. So, but it's to be expected. So remains to be seen though. It's still early days, but you guys have been like, it was cool to see y'all like early on, early this year, just I think jumping straight into it. It wasn't any hesitation, and it didn't seem like it was any BS either. It was like you guys I think had a head start with it just because you're already having a search interface since day one, right? So it's like it wasn't like, hey, let's bolt this on. So It's really cool to see. Any cool stuff you're working on that you think people can learn more about? And if so, how could they do that?
Yeah, so I think the key problem that I've been trying to solve for last few months is how to incorporate users' feedback into the engine that is not just like a point fix, but a broad generalization, right? So if let's say that somebody asks how many opportunities are likely to be won in this quarter, the definition of likely to be won, like our engine can take a guess, but maybe you have a specific definition, right? Likely to be won could be that the sales rep says that they have committed the deal, or it could be that there is a Salesforce probability calculator that says that probability is more than 0.75, or any of those things. And similarly, this quarter in this context is the close date being this quarter, right? So user can give me feedback. I can remember that particular question and maybe even variations on that question. But like, can I infer that when people are talking about winning a deal, then the date filters are close date and apply it to all questions? And same thing, when people are talking about likely to win, then this particular definition is to be used. Can I take that and apply that broadly? So that's been in the works. That product is going to come out very, very soon, and I'm super pumped about it.
That's awesome.
We'll write about it. We'll blog about it. We'll make noise.
Yeah.
But that's the thing that I've been most excited about lately.
That's super cool. Dang, that's gonna be awesome. Keep an eye on that. Well, cool. Wrapping up, Matt and I will be in London next week it's next week, right? I mean, I lost all sense of time and space apparently.
On the
So
20th, yeah.
yeah, so we'll be in London for Big Data London. You gonna be there, Amit?
I know I'm not, but part of my team will definitely be there.
Okay. Yeah, you have an
Definitely
office there.
connect
I've
us.
hung out in your office before. Did a podcast from there, I think, before.
Yeah.
So yeah, good place.
Oh,
Yeah, great people there. So yeah, so we'll be at Big Data London. I think I don't know. Do you want to attempt doing a live show from there next Monday?
Probably
Monday morning data
should.
chat.
I mean, even if it's not the usual time, maybe we can announce it in a couple of days and just do something. Let's figure it out, Joe. That sounds like fun.
Okay, yeah. With my luck, it'll be streaming at midnight for everybody. So awesome. So anyway, well, thanks for being on the show. It's great to chat with you. I definitely learned a lot. So yeah, and this will be up on Spotify and available on your favorite podcast platforms as well. So go check it out, and we'll see you all next week, hopefully. So take care.
Thank you so much for having me. This was a lot of fun.
This is a great
Awesome.
conversation.
Great. Thanks
for taking the time.
Thanks, man.
Yeah. Thank you.